Hello everyone, and welcome to the last episode of the MiniClient series tutorial. If you are watching this in recording, please watch first and second streams before starting this one, because we will be building on top of what we built in our previous two streams. And if you're new here, well, welcome. And feel free to stay. I hope that you will still find some topics interesting here. And let's move on to our IDE and to the tutorial. So that's what we had last week, right? We've created a workspace with MiniClient application, which is our application. Hey Peter. MiniClient application, that's our app that shows weather on Mars. We've created a single feature that fetch weather from NASA API. Hey Daria. And displays it. We've created API client, that's our networking layer with interceptor that manages API keys for us. Hey Milan. We've created a Tide DI, and in Tide DI we manage or we have some abstractions for our service locator, Tide design system that holds the design system components, and Tide monitoring that helps us with monitoring, monitoring and observability. And today we will start working on the navigation. And for navigation, I think it's really important to distinguish between two different navigation types or patterns. When you're working on a small application, well, it's fine to put everything in a single place. Like, for example, you create a Go router and handle navigation there, or auto router, or whatever. It's fine to have hello. It's fine to have a single navigation pattern for whole application. However, if you work in an app with like hundreds of packages and hundreds of features, then most likely your navigation package will quickly become messy. And that's why we propose to introduce two navigation patterns. Hey, Alexander. External and internal navigation. So by external navigation, we mean navigation that probably you are used to. Most likely you already have this navigation implemented in your applications. Like things that you typically build with AutoRoute, Go router, whatever package you prefer. However, and external navigation acts as a glue between different features. However, inside features, we found it's quite beneficial to have another navigator that's responsible for actually navigation and presentations of features, of screens inside of a feature. And with external navigation, I think it's more or less clear, like it's just the navigation that you already have in your Flutter apps. But with internal navigation, things might be a bit more interesting, and that's why, oh, hey Anna, hey from Google I.O. Yeah, internal navigation is far more complex, and that's why let's work on it. So implementation of internal navigation is covered in this document, and we call such navigations flows, and that's why we call the package, utility package that handles navigation for inside the feature flow. Let's create a new package. Oh, and by the way, one more thing. I watched some analytics, and I'm surprised by the amount of you who watch the stream from mobile devices. I'm sure you cannot see anything there. That's why let me increase font like that. I hope that will be better. Right. let's start with the package. So I need to create a new utility package, and I will call it feature flow. Oh, right. Sorry, let's remove this one. One more time, I need to create a feature flow package, and I will create a pubspec YAML file there. Let's copy paste its content. And we agreed to bump environment and use workspaces. That's why let me go here and copy environment constraints into the environment. And we need to set resolution to workspace. And of course, we will need to add this new package to the workspace. It should be somewhere here. Utility feature flow. Yes, that's correct. Now we need to change dependencies because I need to bump get it to the latest version like that. And most likely now that will work. Yes. As you may see in this code listing, we are using Flow Builder for internal navigation. And yep, I've read some comments that this is a controversial decision because feature flow package. Audio? I don't know. I will try to talk louder, but folks, please write in the chat. Do you think that there is a problem with audio? So yeah, Flow Builder. It's been in version 0.1 for quite some time. There are some issues that, by the way, at Tide we fixed, and I think that we need to clean up the implementation and make a pull request. But this package is more than good enough for our current purpose, and I will give you a hint what to do in your packages if you decide to use this approach in your code. So let's stick with Flow Builder for now. Next, of course, analysis options. We need to copy paste this one from any package here. All right. So now analyzer rules are applied for this new package. And now we are creating a featureflow.dart file. So that would be lib src featureflow.dart, like that. And let me copy paste this long file. And after that, I'll describe what's there. Okay, so here is our huge file. Please create the PR. Deep linking, yeah. So in this file, we define a feature flow widget, and that's the widget that manages the navigation stack inside our feature. We pass 3 parameters to this widget. OnGeneratePages. OnGeneratePages is a function that actually converts some model or feature state into the navigation stack. You will understand that soon. So we pass initial state for this feature and flow initializer. Flow initializer, let me show it here what's done. So when we initialize this feature flow widget, in its state, we are pushing a new scope for this specific feature instance. And that allows us to register classes or instances or factories specific for this particular feature. That allows us to really encapsulate many things in the inside the feature package. And you will see this soon. We are creating a controller, and that's a common pattern in Flutter applications. Like, for example, if you want to control text and editing like text entry field, then you have text controller. If you want to control scroll, you have scroll controller. If you want to control flow, you have flow controller. And we register this flow controller in our service locator so that we can get it from service locator when needed. We define a function that will actually initialize the flow, and we will be waiting for this init future function to complete before we actually show anything. In the dispose, we are doing same things but in reverse order, like, or maybe not reverse order, yeah, but still same things. Like, we are dropping the scope, so that will free some memory for us, and we are disposing the controller, saying that, all right, we are not interested in controlling the flow anymore. As for the visual representation of the feature flow, it's just a colored box with scaffold background color. Like, while it's loading, we're showing a sized box there. And when it's loaded, then it will show a flow builder. Like, it will delegate the process of building the navigation stack to flow builder by providing this onGenerate pages function. And in original flow builder implementation, we pass two parameters. And the first one is S, it's our state, right? And the second one is navigation stack. And I found that I don't really know why we need second parameter. I see many ways how it can be misused, and not that many cases where we actually need this parameter. That's why in our implementation, we will not use it, we will hide it here. That's why it's represented as underscore. And of course, that's the controller declaration. So under the hood, it uses flow controller from the package that we use here, and it exposes two functions, update and dispose, so that when you need to update the navigation stack, you will call the update function, and you will see it soon how we use it. And that is a really tiny package that consists of a single feature. So let me create a barrel file for it. We'll call it feature flow, and I will just export this only file from it. At Tide, we have far more advanced feature flow package, because that's probably the simplest implementation of the feature flow. And we needed to cover some edge cases, we needed to optimize it for specific cases, and that's why we have several feature flows in our code base. But I think that you are fine with most of use cases with this simple feature flow implementation. So don't overcomplicate if not needed. In this tutorial, we are using feature flow. We are using flow builder, sorry. But you may achieve the similar functionality with autoroad. If you add autoroad dependencies in your features, and if you play around with its declarative navigator, you can get similar results. So that's a bonus exercise, and it's kind of tricky, and I will definitely not be able to do that in some reasonable amount of time. So we will not do that today, but I challenge you to do that. When you'll have some free time, that might be fun. And of course, like, if you want to challenge yourself even more, then you can build your own version of the flow builder. And it's not that hard. It's easier than you think. However, you would need to deal with many edge cases there. And by implementing your own flow builder package, you will learn a lot about navigation and how Navigator 2.0 API works. So that might be a good project for a weekend for you folks. But for this tutorial, let's just use what I have here. Now we need to go to Marvel characters and introduce a state for the flow and introduce the flow itself. So, speaking of the navigation, like we need to come up with an idea of navigation and where we will navigate to. I propose to create one additional page in our feature, and that page will show some additional details regarding temperature, regarding the weather. And our original MiniClient tutorial covered Marvel API. Marvel API is down, so we will need to improvise here a bit. Let me create a flow state. So it should be under SRC. And as flow is such an important class, such an important thing in a flow, it deserves its own folder. So I will create a flow folder and we'll put inside weather state class. That would be a model. So let me use my shortcut and yep, it generated it for me. Clearly, we don't need serialization there, so let me remove this boilerplate stuff. And speaking of the state itself, there will be, like for example, temperature. I remember that we've added temperature model there, so temperature, and it should be required, right? Like that. All right, so let me run code generation so that we don't have any errors there. Oh, and frankly speaking, before running code generation, I suppose it's somewhere in the documentation, but I need to add a new dependency here, right? So let me add a new dependency. It's called feature flow. So somewhere here, feature flow, path, utility feature flow. Yep, that's correct. Pub-get, it's done. Let me rerun code generation just in case. And let's get back to our model. Here, there is a tricky part here, a tricky thing. I define model as plain Dart model. Of course, it's freezed, but we're using freezed to get some comparator, toString, and other things implementation. But in essence, that still is a plain Dart model. And you might want to use unions here, implement multiple states for a flow. And I highly suggest you not to do that, because if you create a state per screen in your application, you kind of couple your flow state to navigation stack, to pages. And I find that's rather limiting. If you think of a flow state as a state of a flow, as a model that makes sense for the whole flow and that holds information that makes sense for the whole flow, then it would be so much easier for you to refactor this flow later on when navigation stack changes. And if at some point you decide that you don't need to show a new screen, you need to do something else, like for example, you may update existing screen with new information, well, you easily can do that if all information is stored in plain Dart class and not in unions. At the same time, sometimes you should break that rule, and sometimes it makes more sense to build a union. So that's really up to you. But I suggest you start with a plain Dart model. And now let's build the flow itself. So that would be inside weather flow. Oh, I think that we had a convention that, yep, I needed to put a flow state here to make it crystal clear that we are talking about flow state and not just some random state. Let me just regenerate this file. So required temperature, temperature, like that, without JSON serializable boilerplate, like that, and missing import, done. Alrighty, let's work on the flow now. I will copy paste this listing and let's see what's going on here. So unfortunately, I will need to drop all that stuff there. And we have inside weather flow class. That's why let me rename things here and there. So the widget should be inside weather flow and it operates inside weather flow state. Let's import it. Flow initializer. We have a flow initial inside weather initializer for it, and that's important to import not the barrel file here, but the file inside the package with src somewhere in its path. Otherwise, you will see some problems with performance of your code generation, and overall it's easy to create circular dependencies if you import barrel files inside a feature. So don't do that inside the package overall, not only feature. Default state would be just the default state like that. The named parameter temperature is required. Aha, that's why. That's why we have no required there. Let's remove it because temperature is not required. It can be null. And what do we have in our flow? We have a function that converts state inside weather flow state into the navigation stack. In our navigation stack, for now, we may have only insights weather page because that's the only page that we've implemented. Let me add it here. And if temperature is not null, then we can display. No, I don't have any Spring Boot tutorial video. That's an unexpected question on a Flutter stream. We don't have any other page here, so let me comment out it for now, but we will get back to these two lines really soon. The tutorial proposes us to build another page. Let's do that. So we define page in presentation layer, and here it's characters details page. I will call it temperature details page, because why not? Let me copy paste this code. So we will call this temperature details page like that. And it should accept a temperature model. So that would be temperature. And of course it is required because we want to show details there. And in the app bar, we will display, we will show some temperature sol, why not? And here we have, I don't know, temperature details. Add more details here. Okay, so that's the most trivial page that we probably can come up with. Let's use this page in the flow. Let's get back to flow. If temperature is not null, then we can display temperature details page and pass temperature as a parameter. What's interesting here? I don't really like this force unwrap because force unwraps are bad. And with new Flutter syntax, we in fact can fix that. So I think if I keep forgetting the syntax, but I think it's like that. So we're using pattern matching to match temperature model. And if state temperature is not null, so if temperature will be not null, then we are using this temperature variable and will pass it to temperature details page. That should work. Alrighty, what do we have here? It's time to implement the navigation. That's so true. Let's go to block first and implement another event. Peter, is that the only new thing? I hope you may learn more things from that stream. So here we will define a new class. Let's call it Open Insights Weather Event that will extend Insights Weather Event, fix the constructor here, and we will pass a temperature as a parameter to this to this event. All right. I think we should update this guy too, because right now it's not possible to instantiate this class from anywhere. That would be open with a parameter temperature, like that. Alrighty, I think that should do. I wonder whether everything is fine with the stream, because I see some loading indicators from time to time, and I wonder whether you can see and hear me well, or maybe something is off. Please drop a comment. And meanwhile, I will refactor block because now it complains. Cool. All right, let's fix this guy. So if it's Open Insights Weather Event, then we need to handle it on open, just on open. Why not? And let me implement this handler. I'm so used to use ChatGPT, ChatGPT, Copilot or Cursor here, because that's just boilerplate that usually you don't implement yourself anymore. But here, let's implement this one. All right, on open, we don't need to manage states here. I'll remove emits. And here, what should we do? We need to update flow's state. That's why we need to define a configurator here. So that would be a feature flow controller with insights weather flow state parameter or template, like generic. Let's call it controller, and pass it to the constructor, this controller. So what should we do in our handler? In our handler, we will call controller.update. Here we have a lambda function with the only parameter which is current state. So we will copy current state with new temperature value, and we will get it from the event itself, like that. And that should do the navigation in our block level, on block level. However, we still need to raise this event from somewhere. Let's go to Insights Weather page. Here we have list view builder with list style. Well, why don't we use on tap here? I will need to get a block. I will use context.read. That should be something like Insight Weather block. And I will emit a new event here. That should be something like Insight Weather event. Open temperature, and for temperature, I will use temperature index, like that. I guess that should work. So we've done one improvement here. We now initialize feature inside the feature. We don't need to export it anymore. And the page itself became a detail of this feature flow too. So we don't need both of these exports anymore, but instead we will export flow, something like inside weather flow.dart, like this. And that's really great because now we have only one. I still see some progress indicators there. Something is always internet today. And that's really great because the less entities, the less classes you export from your package, the easier it is to maintain this package for you. Let's fix our DI now. We don't have feature DI initializers anymore. Let me just remove this code from here and here. And in the presentation layer, in the boot, now we have insights whether flow instead of a page, and flow knows how to manage its state and what to show there. And I guess that was it about this application section. So here we just removed this guy, and for builder it's fixed too. Bonus exercises: implement proper external navigation. You can do that, but it will take some time for me, so we will not do this during this stream because we have another exciting topic for today. And we should complete our details implementation. Well, for sure, that makes sense. Let's try to run the application and see whether it works. So somewhere here I have my simulator. And let's see. Okay. So NASA API still works. That's great. And when I click somewhere, I see details. So we've implemented declarative navigation without really doing this imperative push, pops, other things. Now navigation stack depends on flow state. And I don't know, I think it's really powerful, and you can build quite complex navigation stacks with this approach. However, if you see that your mapper function that maps a state model into navigation stack becomes too complex, then that might be a hint for you that it's time to really think again about your feature. Maybe the feature itself became so complex that you need to split it and extract some packages from your feature package there. And that was it for navigation. And I don't see any comments in the chat, no questions, nothing. I hope that you're still with me. It was either too easy or it was too unclear what I just implemented. So I don't know. I hope you are still there. But as there are no questions, let's move on to our next topic, testing. And testing is my other favorite topic. Thanks, Peter. I suggest you to think of testing like there are two ways you may think of your tests, and two different approaches. They are called solitary approach and sociable approach, like solitary tests and sociable tests. And the difference there is in their scope. In solitary approach, you are focusing on a single class. And in sociable test, you may use many classes, many entities. And that's really interesting. Like in solitary testing approach, you mock every third-party dependency for this class that you are testing. And in sociable approach, you are doing things slightly differently. And I think that sociable approach makes much more sense. However, it might be more complex for understanding. That's why this tutorial starts with unit tests. And in the tutorial, like if you've done the tutorial, the result is already covered. Yes, it should be. However, the tutorial proposes us to focus on monitoring. Well, okay, let's cover monitoring package with solitary tests. For that, we need to add two more dev dependencies to the monitoring package. Let's go here, pubspec YAML, two more dependencies, like that, pubget. Okay, all good. Let me stop the application. We don't need it anymore. Creating mocks. Oh, so in the original tutorial, we used Firebase Crashlytics as a dependency, third-party dependency for the package. And I think for this implementation, I decided to oversimplify things and use just developer.log. Alrighty. Let's change this a bit. Let's introduce a new dependency, which can be a bit artificial for this monitoring package use case. At the same time, that will make this monitoring class a bit more real. So I will define abstract class, which I will call logger. And we may implement different loggers. Like for example, here I can add simple logger, and it will implement logger. So inside the logger, I will have future with log, like let's just copy this signature of this method, put it here. So now we need to implement it, and that would be our implementation, but we don't want this implementation to be too smart, and we don't want it to add any prefixes here. So it will just log whatever we asked it to log. That would be our simple logger. Here I will implement it as a lazy singleton, but I will use constructor like that because I need to register it as logger. Okay, that will work, but I'm already unhappy with this implementation, because with this implementation, I can have only one logger in my code base, and that's not exactly what I want. Alrighty. I still see some loading indicators. So I wonder whether you are here. I think I'm back, right? Probably something is not working quite well for me. So let me know if, yes. Oh, only 3 seconds. That should be fine. Yep. So I said that I'm unhappy with this implementation because that allows me to register only one logger instance, and I want more. I want to pass probably list of loggers here. So that would be loggers like that. I will remove this guy then, and let me create a DI module where I actually can register multiple loggers. let me create DI module. That would be an abstract class. DI module, why not? That's a module. And in the module, that would be a lazy singleton list of loggers. Logger. Alrighty, barrel import. We already know that they are bad. Create loggers. Let it be like that. So I need to import it with src. And here I will create a list of loggers. So it would be a simple logger. The constructor being, oh, we don't have a constructor here. Such a shame. No, I want to have a constructor for any class that can be constant. So that should work. I need to run code generation in this package. So let's do this now. And let's see how it changes our DI initializer class. Now it's created a new class for DI module, and from the DI module it takes the factory for loggers. It registers list of loggers like that, and so then it passes this list of loggers to our monitoring. Let's use these loggers, right? So here we will call future wait and pass list of futures. So we will take all our loggers and what's that? Loggers, and for each logger, for each, it will complain, our linter will complain if I use like that. All right, let's not use future wait. Let's just use for each for final logger in loggers. I will call it like that. Logger.log my message. Oh, but I wanted not just log a message, I wanted to make a prefix there. So it would be log message. Like that. I'm happy with this one. So let's follow the tutorial. Get back to the tutorial. Tutorial suggests us to create a mock for loggers. That makes sense. Let's create a folder for tests. So it should be test, and it would be a utility folder with logger mock.dart file. There we will create a class that is mock logger, which will extend mock from mocktail and implement logger from src monitoring. Now we need to create a function that will instantiate this logger. So it would be create logger mock. Here we will instantiate that mock logger, and we'll set up it in such a way that if someone is calling mock log function with any string, then we should answer invocation is empty. We should answer with nothing, like we don't really need to do anything. And let's return mock from this function. I think that implementation is really similar to what we have here. Okay, now we can write a unit test for monitoring package. So test monitoring test. Monitoring test, and this file will have a purpose, like we will write tests for monitoring class only here. Monitoring, let's fix some imports. It should be monitoring type monitoring. No? All right, we will import it later on. We'll import the utility. So monitoring tests. Let's import monitoring. Crashlytics log. We have not Crashlytics log. It's it can be mock logger. It can be just logger. I would propose to keep mock here, just for clarity. That yep, for sure that's mock. So we'll have logger mock here, like that. I need to instantiate this logger mock. I already forgot how the function was called. Create logger mock, okay, like that. That makes sense. Let's return mock logger from this function then. That should do. And monitoring accepts a list of loggers, so I will use logger mock here. Tracking event should call monitoring, should call logger log. So that's our event. It's in arrange. And by the way, arrange act assert pattern. I highly suggest you to write these comments in your tests if you are not sure what you are doing with tests, like overall, and if you know what you do with tests, because that really creates some sort of a structure for your test, and you may immediately see when you are preparing for a test, see what you're actually testing, and there might be multiple assertions here. While the logical assertion will be only one, there might be multiple lines here. So to me, it makes sense to keep these comments just for visibility and overall simplicity. We need to fix some things there. And I see we have misprints in the tutorial. Alrighty, so we called it log. When system under test is invoked with this event, then we verify that logger mock dot log was called with log event function, and it was called one time. Is that it? Because it should be. Yeah. How do you structure tests where you act and assert multiple times? I don't, because when you need to act multiple times, then you are mixing multiple tests in a single test implementation. So I suggest to restructure your tests. And by the way, our tests pass. Alrighty, so Peter said that he already learned everything, and I want to show you more things. So let's do a bit more here, and even more later on when we'll be working on other tests. Let's actually see what's going on with our application and with coverage here. There is a utility that I highly suggest to use for everyone. It's called spec, and you may run spec, you may install it from pubdev. You may watch it in watch mode with coverage parameters, like in this folder. It will run our tests, but it will not only run tests, it will generate a coverage for us so that we can see which lines are covered, like that, with coverage gutters plugin that I have installed here, this one. I think it's just a must-have for every Flutter project. Like, use coverage gutters. It really helps to visualize what's covered, what's not, which tests are missing, which requirements are not covered here. And what I really like about this package is that if I change the implementation a bit, like for example, like that, it automatically rerun all tests, and I immediately see the feedback from my environment that I broke something. So when I'm working on a feature, usually I have spec running in background so that I can see what's going on there. And the moment when I see failed tests, when they're not supposed to be failed, then, well, that's a reason for me to think what's going on here. Yeah. Alrighty. I guess we are done with this monitoring class implementation. And that shows how solitary approach works. It worked because we had requirements for this class. Like here we're saying that, all right, we have a monitoring class, and for monitoring class, when we call log, then we ask some third party for monitoring class that it needs to be called with log modified log parameters like that, and it was called only once. We had requirements for code, but for our features, we don't really have any requirements. Like, no one really cares about flow. No one cares about pages, about block, about repository. All we have is a requirement for the feature itself. And that's why we will use slightly different approach for MiniClient testing, for inside weather testing. Let's add one more dependency here. Creating, alrighty. Yeah, probably. But probably we need to do some preparation here before we actually start working on inside weather tests. Completely forgot about that. We need to create a package that will help us to simplify feature tests. And we call this package test utils. All right, that's yet another utility. Let me create test utils pubspec.yaml file like that with the following context. As usual, I need to fix environment. Let me copy paste it from here. Like that, and I need to tell it that resolution for this package is in workspace, so I need to add it in the workspace now. Test utils, like that. Something is not working because test utils depends on monitoring from path, which does not exist. Really? Really? Because we call it tide monitoring. And now it works. Great. So I think it's still a good moment in time to talk about sociable tests, because I see that we are building an interceptor, and you might be wondering why. And the reason is that we have only user-facing requirements for our features. Like when I open some screen, then I see, I don't know, some widgets there, some text. So when I interact with these widgets in a certain way, then something happens there on the screen. And if you follow any test first approach, then what do? You transform these requirements that you have into code. That's the first step. On the second step, you're writing the worst implementation possible. And I'm not sure about you, but to me, the worst implementation would be to put everything in a single file. I would not care about widgets too much, about state management, definitely not, about repositories, use cases, API layer. I would not even bother about models, because I can use map of dynamic instead of data classes everywhere. So my only goal is to make test pass, and at some point it will pass. And then on the third step of test first approach, then you refactor, and there you extract some things. Like that's the moment in time when you care about solid principles, and you are maybe even introducing clean architecture in your features or whatever other best practices you decided to have in your project. However, API will be an implementation detail of your block, because frankly speaking, like let's go the other way around. Like you had a widget, so you could extract some more widgets from one widget, right? And at some point you may refactor all your set states or the absence of state management into block. So that's where block will appear. And at some point you will introduce use cases, repositories, but all of them were implementation details for your block or API layer or overall your feature. That's why we're saying that the entry point to your functionality, to your feature, would be feature flow, because it's the only class, it's the only entity that's visible from outside of the package. And that's the only class that we can actually test and that we actually should test. And all other classes are implementation details there. So we want to use real implementations in all these classes. That's why we are building a special interceptor for DO, for networking layer, because we plan to use real DO instance in our tests. But we don't want to make any networking calls from our tests, because that will make our tests slow and they will depend on the environment. Like let's imagine that NASA API will be gone tomorrow. That will fail all our tests. And we definitely don't want that. We want our tests to be stable. So we don't want to rely on real API. That's why we will mock the request and response from NASA API. Let's build this interceptor. I need to copy paste analysis options, of course, here in test utils, paste, and let's create a new file. It should be libsrc test interceptor. I guess one test is enough. Interceptor Dart. And let me copy paste this implementation. Let's find out what's there. So feature test interceptor. Why don't we call it feature test interceptor then? Rename feature test interceptor is a class that extends interceptor, and it has two fields, private fields, mocked requests and mocked failures. So we may register some JSON on the path, and it will go either to mocked requests or mocked failures maps. And we override on request in this interceptor. If we see that the request or API is mocked in mocked requests in our kind of success cases, then we will resolve this request with some response like that we predefined. And the same for failures. If you see that we mocked backend with a failure response, then we just resolve the request. We are rejecting it with DO exception and some predefined JSON. If not, then we throw an exception. No mocked request found for this path, and that's definitely something goes wrong. So we were about to make a real API call, and we agreed that it's not a good idea to do so. That's why we will throw an exception. Mocking monitoring. Well, let's follow the tutorial and mock monitoring as well. That would be monitoring mock. And we are using mocktail to actually mock monitoring. I guess it's tide monitoring. And when we log anything, then we're just returning a future. frankly speaking, we can use real implementation here because we are not using Firebase anymore. Like in the original tutorial, we mocked monitoring because there was crash latex and we used real Firebase in test, which was clearly a big no. That's why we mocked monitoring. In our implementation, we have simple monitoring that just writes some data to console, which is not a big deal, but still, why not? We never know whether new loggers appear in our code base, so that will make our tests slightly more stable. TestDI initializer. We need to create a special test container for our tests. That would be test container.dart file with the following context. Alrighty. Here, I guess I called it monitoring mock, right? Monitoring mock, like that. Let's quickly review what we have here. Here we have test container, which is a TidyDI initializer, which is kind of container for initializers from first stream. And we have an init method that registers everything in our service locator. So we have feature test interceptor that we just created here. And we register it as singleton because we might want to get it from service locator later on. And we create a new Dio instance and add an interceptor there. We can reuse, frankly speaking, we can reuse the same constructor that we use in real implementation from API client utility package. But not necessarily, like we are interested in Dio, and it will still be kind of mocked. So let's just use this Dio instance for simplicity. And we are registering one more singleton that would be monitoring. Alrighty, one more class, one more helper. We call it initFlow file and initFlow function. So that function will tell widget tester, which is an entity from a Flutter test package, that we are interested in this widget. Like we will pump our application, and we are building a new application here from the flow that we are going to pass. Flow is just a widget, so we pass a function that returns a widget, and it will make much more sense when you will see an example of how to use this. And there is an initialize DI container function that initializes DI container. Surprise, surprise. That's absolutely the same thing that we've done in MiniClient. I guess somewhere here in boot package, init di, initialize di container, and in the real implementation, we needed to register monitoring and API client. And in our implementation, let's get back to init flow. In our implementation, we've done kind of the same. So in test container, we initialize monitoring and API layer. So it's really similar to what we have in the application, but everything is optimized for tests. And there is a problem with this implementation for now. Like we are initializing DI containers. So if we run multiple tests, they will reuse the same container singleton, which is not what we want, because that's so easy to mess up with configuration there. That's why we are going to reset our service locator container, and the tutorial proposes to do this in the initialize DI container function. That's may not be the best place for that, but that's definitely good enough for this tutorial, so we will keep it here. Why is it not the best place? Because, well, it looks weird that we are changing the production code for our tests. This is wrong. Usually we should not do that. Usually we tend to isolate changes, like everything that's related for tests, should not impact in any way our production code. And here we're modifying production code, which is unfortunate, but that's absolutely not a big deal. All right, it's time to create a barrel file for test utils. Test utils. Would I normally place it in setup or teardown? I guess I would place it here in init flow, because all that logic is coupled with init flow, and I think that it makes more sense, but I don't remember why I've done that in initialize container, so I'm not doing this right now. Yeah, because that's a live stream and something may go wrong, but I would put it here. And let's export interceptor and init flow files from this file. Great. Feature testing. It's time to start testing the feature. Let's move on to insights weather. I need to add more dependencies. BDD widget test, Flutter test, mocktail, and test utils. Quite a list of dependencies I have here. Like that. Okay. That's fine. And I guess I should run code generation here. Alrighty. While it's working, let's prepare testing data. Let me collapse this one and create a new folder and new file. So test util data.dart. And for data, we define two variables. The first one is error. And frankly speaking, I have no idea what this API will return in case of an error. So let's pretend that it returns an empty JSON. And for success case, we need to return the real API response. And it's really important to copy paste real API response here in your tests, because that would make your tests more real, if it makes sense. So let me copy paste everything. I know that we ignore most of this information in our implementation, but it's important to have everything here in tests. And of course, that's not a list of characters. That's just, I don't know, success. Let's get back to the MiniClient tutorial. We are ready to write a feature file. Frankly speaking, you don't need to use Gherkin here. However, I found it beneficial to write Gherkin files. Let me create a file here, weather.feature. Why? Well, you may write plain old feature tests there, and then you start conversations within your team, like how should we structure our tests, when to reuse something. Especially, you'll have a lot of conversation with folks who never wrote a test, or with junior engineers who are just trying to understand what's going on there. If you try to show your tests to non-engineers, to, for example, products or someone, they will understand nothing from your code. That's why I think that it makes a lot of sense to use a BDD approach and create feature files, because they will write the same code for you. Like, for example, that's a Gherkin file that describes our feature. It's not Marvel characters anymore. That's temperature or inside weather. That's inside weather feature. So given I'm on the inside weather page, and that's our like background. That's something common for all our tests. And what we want to test. So inside weather page or flow should display a list of temperatures. So when backend responds with success, then I see a list of temperatures. And when inside weather flow should display an error if NASA returned an error, something like that. So when backend responds with error, then I see an error message. And that's it. Let me save this file. And do I have code generation? I do, but why I don't see anything here? Let me run pubget. Oh, because I do have code generation and test utils. Wrong package, sorry. Let's run code generation in the correct package now. Yeah, now I can see it. It's doing something. Yay. And it generated feature tests for me. So these are a group of tests inside weather with some setup, with some test widgets, and all these other functions that I would need to write otherwise. And it's already prepared some files for me, like here. Now I just need to implement these functions in these files. Let's start from probably the beginning. So I'm on the Insights weather page. What does it mean that I'm on Insights weather page? Well, that means that I am on this flow. So here there must be Insights weather flow. And inside init flow will initialize DI for us and pump the appropriate widget. So that should be it for this implementation. So the backend responds with something. Let's copy paste this implementation too, like that. And we need to fix the path. I think that for our feature, let's go to domain, API, and API weather. The path is different. Let's copy it from here and place it here. So when the path is inside weather, then we need to talk to interceptor. And when scenario is, I guess I call it success, then we need to mock a request with success scenario, like that. When the scenario is error, then I need to mock interceptor with some failure there. Otherwise, we will throw argument exception that was an unexpected scenario name. And we pump and settle here. Why we pump and settle? Well, most likely there will be some loading indicators there, and unless we want to test actually this actual indicator, this loading process, I guess it's fine to settle and wait for everything to be settled there. Righty, let's move on other things. So what does it mean that I see a list of temperatures? Well, that means that I see text. Let me use I see text function from BDD widget test. So I can await a text, and there will be a text like sol something. Let's check this one. So sol 675, like that. And there will be sol 676, and maybe I can be a bit smarter and implement a for in. So I'm looking for a temperature in the following collection. I think we had it in data somewhere here, Let's grab that list of sols. Yay. Here we have all our sol keys. So I will put them here. And when I see list of temperatures, that means that I see these texts there on the screen. Alrighty, and when I see an error message, then I see some other text. DO exception, really? We show DO exceptions there in presentation? I don't believe that. Let's see. No, in our implementation, we are showing something went wrong. So here the implementation would be similar. Await, I see text, tester, oops. Something went wrong, like that. That should do. The tutorial describes a problem with images, and in our original implementation, we showed some superhero images there. And Flutter tried to fetch these images from internet, and of course, it fails to do so. That's why, to prevent networking calls from Flutter framework, you needed to use, for example, mocked image network package, and it would kind of intercept calls from Flutter and will substitute all images with some blank pictures, like images instead. Or you may do simpler implementation and use, for example, cached network image that will handle it for you. And even better, it will put all these images in cache so that your users will benefit from that implementation too. Let's see what's going on here. Let me run tests, and I can run them like that, spec, coverage, and see what's going on there. Alrighty, one test passed and one failed. That's interesting. Let's see. I see that it says 0 widgets found with text sol 7c5. That's interesting. Maybe it's not sol. Maybe it's something else. Oh, it's sol, but with capital S. And by the way, look, we already have Alrighty, I think something is wrong with my camera. So many things went wrong with the current stream. Let me switch the camera. RIP camera. Yep, that's true. It says that heap is there. So let me use this camera instead. Oh, hey. I hope that it's not that worse. So I don't see you. Hello again. It's S with a capital S here. So let's fix our tests. And the moment when I change tests, you may see that it's supposed to rerun our tests. I'm not sure whether that happened. Let me check again. All right, so it tried to run tests, but it says that sol 765 is not found. That's interesting. Why is that? Let's debug our tests. Well, that's the joy of live streams, right? Sol 765. Let me see one more time here. Yes, so without any white spaces, without anything. All right, there is a simple way to debug feature tests. I can use debug dump amp function that will just dump the widget tree. So here, when I expected to see something, debug dump app, I can use this function, and let me even set a breakpoint so that we can run our tests in debug mode and see what's going on there. This one, success. Maybe it's not success, maybe something was not really mocked properly. Let's go to debug console here and see what we see. All right, so there is Sol 681, this one. There must be Sol 675. That's interesting because here it is. I see Sol like that. Okay, sorry, my bad. Let's run tests again. And now we have 2 tests passed. And I think that maybe that was it in the tutorial, and we have some bonus exercises there. But I'm unhappy with this implementation because if I open block here, you could see that something is not covered, and it's really easy to get 100% coverage with this approach. Why don't we cover all cases here in our tests? So let me add another feature for this file, and it should be temperature details, something like that. So the scenario would be the following. When I click temperature, I can see details, something like that. The background is similar for this scenario, so given I'm on the Insights weather page, and then it's slightly different. So when I tap Sol, what was that? Sol 765 text, then I see what we have inside temperature details text here. Okay, that should do. Let me run code generation here, and code generation should generate a new feature test for me. Okay, so here I have new testing group, temperature details, with this new test widget. Here I see the same invocation, and here I have when I tap text, and the framework is smart enough to understand what you want it to do. So I tap text, it already created a predefined implementation for this guy. And for I see text. So let's run our tests again with coverage, of course, and we have failing test, of course. Found 0 widgets with test Sol 75. I wonder why is that. Let's check it again. Because I needed to set up the backend. So when the backend responds and I tap like that, I need to rerun code generation now. Come on. And that will add this additional missing line to our file. And now I will run it again. And by the way, all tests passed. And if we look at the coverage, then our blog has 100% coverage. So as details page, so as just page, so as what's important, these files. Like here, we don't have 100% because we needed to add tests for some edge cases that are not really even possible in our implementation. Like for example, if response type is plain, we don't have this response type. We always use JSON. So you cannot get 100% of coverage with this approach. However, I would suggest you to just remove code generation from your test coverage report. And that would allow you to really focus on what matters, on, for example, deserialization. If your model never supposed to be serialized, then it makes no sense to test serialization. But well, of course, you should fine-tune your code generation and to just ask it not to generate things that you don't need. However, that's not always possible. And for example, here it says that's file uncovered. Well, so what? That's why I suggest you to just drop code generation from all packages and focus only on what matters in your features. And that's it for the MiniClient tutorial. Let's see whether we have something here. Aim for 100% coverage. Yep, that's for sure. Run tests as often as possible. Use spec because that really helps, and keep tests fast. When you see that your tests become slow, then that probably means that your feature is too big and you need to split your feature into multiple features. Yeah, and that's probably it. So please feel free to write comments under any of these streams. I will try to respond to all comments that are related to this tutorial. And if you want me to stream more and cover some other things like, I don't know, CI, if you want me to deep dive more in a bit more details in BDD, then again, feel free to add a comment and maybe there will be more streams. But for now, that's it. So thanks everyone for joining this stream and have a great evening. Talk to you later. Bye.